So I have chosen 20th individual as my sample, and I have to start collecting the data. So what is the procedure here? So every kth member of the population to include in your sample. So out of my 366 people, I'm going to include every 20th member, whoever going to be in my study out of that 366. As I need 366 is my sample size. I need 366 respondents out of 7,500. So out of 7,500, I'm going to choose every 20th individual until and unless I reach 366 respondents. So that's how I select my sample. So once I have my sample, I'm going to collect data from them. I'm going to collect data from them, whether it can be through survey method, whether it can be through online test, or whether it can be through questionnaire method. I'm going, like, I have selected the sample, and I'm going to collect the data. So when to use systematic sampling? So this is the most important part of any topic, because even when you have a bundle of knowledge about a topic and you don't know when to apply it or when to bring that into action, it's waste of that knowledge. So to start with, you should, when you have budget restrictions, so when to use systematic sampling when you have budget restrictions. So just imagine if you choose simple random sampling. If you choose simple random sampling and you have to call out a simple, what you say, you can't even to conduct a lottery method, you need a lot of time, and even to conduct a random numberized method. So there you need a lot of time, lot of efforts, and as per efforts and time, you need resources. So for that resources, you have to pay. More the resources, the more you pay. So when you hire five question interview people, you are going to pay less. When you hire 50 interview people, you are going to pay more. So when it comes to systematic sampling, that is the advantage. Once you choose the sample, you can have maximum information. What I say is you can have maximum information with less cost, less time, and less efforts. So because of this, what you are going to save, because of this, you are going to save your budget, point one. You are going to save your time, point two. You are going to use less resources to get more data. Three advantages. So inside budget only we have three. We save time, we save budget, we save usage of more resources, and we get more data from the less resources. That's one. Next, uncomplicated implementations. So systematic sampling works in an environment where everything is organized. As I said in the first slide, your population should be in order, your population should be systematically arranged, your population, like you should have a prior knowledge about your population. Only in such cases, systematic sampling can work. Not every time you are going to do, it is going to work. So that is one thing when it comes to uncomplicated implementation. So what is another uncomplicated implementation happens with every research? The most complications that happen with every research is the way we analyze the data. So in most of the research, what we are going to do, we are going to take out Excel sheet, we'll record all the responses, and we are going to filter it. So once you have a filtered view, you'll have some variety of categories like heterogeneous responses, homogeneous responses. Sometimes you come up with a mixed responses. So at that situation, when you have so much of confusions, systematic sampling can't help. Systematic sampling can't help. Even if you apply systematic sampling in such situations, you are not going to get an accurate result or the expected result out of such researchers or the research paper you are going to conduct. So at that time, systematic sample is waste of time and money in such situations. Then absence of data pattern. So yes, systematic sampling, I forgot this point. Okay, absence of data pattern. Absence of data pattern here. So what is data pattern? Either you should know whether it's in alphabetical order, is it in numerical sequences, or is it in the data range. So only when you know the data pattern, you can predict or you can choose an individual. When you don't know data pattern, how are you going to choose? How are you going to choose? Because before conducting the survey, you should know who are your target audiences, what is your interval, what is your sample interval before conducting the survey. So when you need so much of what do you say, preferences for conducting a research, you should have a clear idea about how you are going to conduct, on what basis, on what pattern you are going to conduct. So when you have absence of data pattern, this is highly not possible. You should have a clear data pattern while you are making a systematic sampling. Low risk data manipulation research. When you have low risk of data manipulation, like you're going to conduct a research, but that data cannot be manipulated even by others. Like that data is a raw data, or it can, like something, give you an example. What is it? For example, we are going to conduct research based on the number of telephone or the mobile numbers. So when you have a mobile number or a vehicle number, it is registered in one person name. You can't change that. So the data manipulation there is not possible, right? So what are the types of systematic sampling? So under systematic sampling, we have three types. So which are the three types? One is systematic random sampling, linear systematic sampling, and circular systematic sampling. So we'll go through one by one briefly now. So first we have systematic random sampling. So what is the systematic random sampling does? Under this method, we are going to select samples at a random interval. We are going to select samples at a random interval, particularly present it preset intervals. Let me take an example. I'm going to start a point between 1 to 100, 1 to 200. I'm going to choose randomly. There is no scientific way. I'll verify. As I gave a store example, he didn't use any method there. He was like, you stand at the store and exit point and you interview every 20th customer. He didn't use any logic there. He said you interview every 20th customer who are exits the store. So there was no logic. So that is under systematic random sampling. It is a random selection of your interval. And there are, even for this, we have steps to follow. What are those steps? First, you have to calculate and fix the sampling interval. So as I gave with an example, you are going to refer the prior week's walk-ins, and you will see on which day there is a higher walk-ins, and based on that you'll choose some random number, and you'll say hey, you interview every 20th customer, 25th customer, 50th customer, whoever exists the store. So and based on that you are going to conduct a research. Okay, then you are going to choose a random starting point between one and sampling interval, as I said, the 20th. Then you have to repeat the sampling interval. To choose the subsequent elements. So until you reach your sample size, you have to continue this. You have to continue the sampling interval until you reach your sampling size. So linear systematic sampling. So when it comes to linear systematic sampling, it is not like a random sampling. Here there is a flow in this. There is a flow, as the name states, linear. It has certain linear frequencies in it. So what is that? Rather than selecting n units of sample randomly, a researcher will apply a skip logic to select this. It follows a linear path and then stops at the end of the particular population. So I'll explain you this with an example here. Okay. So for that, I have steps here. I'll explain steps and then I'll give you an example. Yes. So we have to arrange the entire population in a classified sequence, whatever the sequences we are going to plan. 1, 2, 3, 4, A, B, C, D. So based on that, then we'll select the sample size. As small n denotes the sample size and big n denotes the population size. We are going to calculate the sampling interval. That's k equals capital N divided by small n. That's regular interval equals total population divided by sample size. We are going to get regular interval. So we are going to choose a random number between 1 to k. including k. Even k will be my random number. That is the regular interval we are going to choose. Add the sampling interval. Add the sampling interval. We are going to add the sampling interval k to the chosen random number, to add the next member to the sample. So I'll tell you an example to this. Let us take, I have chosen 1 and my k element is 3. So what I'll do 1 plus 3. 1 plus 3. So 1 plus 3 is 4. 1 plus 3 is 4. So what I'll do, every fourth member. So the next fourth member who, like, after from 3, who is the next fourth number? Next fourth number is 7. So my 7th person. So the 7th person will be my sample. So we will repeat this procedure. Until we add the remaining member to the population sample. So until we get the maximum sample we have expected, till then we will repeat this process. Like 4 plus 3, 7, 7 plus 3, 7 plus 3 is 10. So 10 plus 3 is 13. Like this, we'll go on continuing until we meet the maximum sample size we have. Like 366 was the example I gave. In case isn't an integer, you can select the closest integer to n by n. You can choose the closest integer. If it's 20.50, you can choose the closest integer. That is 21 or 20. 20 you can't because it's more than 50. You can say 21 and you can also say 20, though probabilities are 2. So here is an example for it. So as I said, this was the formula. I said n is the total population units, n is the sample size. We are going to calculate based on this. So we have circular systematic sampling. Guys, this is very, very important and this has some unique characteristics. So listen to me very carefully for this part. In this part, we are going to look into circular systematic sampling. So as the name says, systematic, circular. So we are going to have a circle in a systematic way followed, that straight to straight or towards back to back. This is how one circular systematic sampling works. So I want to explain this with a slide. So I'll take a help of the slide here. What I'll do is, so I'll show you the calculation. Circular systematic sampling. Yes. So I'm going to show you the example of circular systematic sampling. So circular systematic sampling. Okay. So how I'm going to show you this? We will look into this formula. Okay. We'll take the given here. So the given here is n equals 7 and n equals 2, and we have to find k. So the given here is n equals 7. That's the total population is 7 and the sample size is 2, and we have to find the k. That is the sample interval. So k equals, what is the formula? Capital N divided by small n. So k equals, what is the total population we have as per the question? 7. And what is the sample size we are sampling? Sample size we have 2. So sample size is 2. So k equals, can you guys, it will be 3.5. So 3.5. So I got 3.5 here. So how will I choose interval? 3.5, I can't say 3. Third person will say half of the response and the fourth person will say half of the response. No, it can't be possible. We have to specify the decimals into factors. So how we are going to do? We have two probabilities. We have two probabilities here. We have two probability. We have two probabilities here. We have two probabilities here. What is the first probability? So the first probability is we can choose K as, we can choose, let K be 3 or the third individual. Let K be the third individual. What is the next probability? Let K be, let K be the fourth individual of population. So these are the two probabilities. So these are the two probabilities. So this is how you have to define when you have decimal points. When you have decimal points. So what is the one more thing is important here? So when you observe here, we didn't have K value. Some cases we'll have the K value, like as we saw in the previous example, we'll directly have the 20th individual as our K. But here we don't have anything as such. So we found out the K here. But there are two probabilities as we found out because we got a decimal integer because of the decimal. So because of decimal, we got two probabilities. That is third and individual. So this is how it works. So this was the example I explained with. So this has to be represented diagrammatically to bring out the results. So here I'll draw a diagram also. Wait. So yes, insert shapes. So I'll choose this. I'll choose a circle. So when you choose the circle, because it is a circular systematic, as the name says, we have to choose a circle because it is in a systematic way. So after that, we have to have some boxes here. So under this, we have A. B. We will have B. We will also have C. We will also have C. And C, E, E, D, B, C, D, D. C, D, E, E, A, B, C, D, E. Yeah. And A, B, C, D, F. BCDEF. This is going to be G. So 1, 2, 3, 4, 5, 6, 7. So this is my population. So how this is going to move here is, I'll show you that. We are going to which one? This. Yes. I'll draw a line from here to here. And same like this. A, B, C, D, C, D, E, C, D, E. So this is how the circular systematic starts flowing. Wait, I'll show you this. Okay. So this is the circle. So after this, I want to show you what will be the outcomes. I want to show you the outcomes here. If I choose 3, if I choose every third individual, my outcome is going to be BCD. My outcome is going to be BCD, every third individual. Then next, if I choose every 3 individuals, BCD will be 1. Then after that, I'll have CDE. CDE. Then I'll have DEF. Then I'll have EFG. Then I'll have FGA. So this is how it flows. If it is my third individual. So what if it's my fourth individual? I'll show this side. So you'll have a clear idea on this. So it's the fourth individual. Second. A, B, C, D. So B to D. So BD, C, DF, EG, FA. In the same way here, if it is a fourth individual, it will be for the fourth individual. Fourth individual, it is going to be B, E, B. It is going to be B, C, B. So B 1, 2, 3, 4. 1, 2, 3, 4. From B it's B, E, and C. We have 1, 2, 3, 4. C, G, C, G. Next we have D, 1, 2, 3. D, A, C. So when we have an interval of 3, we came with the 4 outputs. And when we came with the fourth individuals, we got 3 outputs. So like this, it varies from person to person, time to time, and from situation to situation. But it moves in a circular way, as I mentioned here. It moves in a circular way. It is going to be a systematic circular way. If it's moving towards the forward circle, it is going to be in the forward way. If it's moving towards the backward circle, it's going to be in the backward way. So this was one. So next we are going to see the steps which I explained in the previous one. So calculating sampling interval k equals n divided by n. If n equals 11, if n equals 11 and n equals 2, then k is as 7, 5. Okay, k is 5, not 6, because 11 by 2 is how much? 11 by 2 is 5.5. We'll choose 5, not 6. Start randomly between 1 to n. We are going to choose randomly like 1, 2, 3, 4, 5, 6. A and F will be our interval, or like they will be our sample. Create samples by skipping through k units every time. Yeah, that's what I did here. See, I have started from A, I have skipped the A element. I've started from B, I've skipped the B element. I've started from C, I've skipped the K element. I've started from D, I've skipped this K element. So you have to skip the every kth element, while you are doing a representation like this. In this method, in this method, or in this case, the n number of samples, unlike k samples in the linear systematic sampling method. It is going to be a linear systematic sampling method, but it has a circular process or a circular systematic method in that. While it was moving in a linear way, it is going to be in a circular way. With this, I have one more slide. Yeah, the last slide of the session. So with this slide, I'm going to explain you what are the differences we came across linear systematic sampling and a circular systematic sampling. So under linear systematic sampling, we create samples. K, sampling interval, and we create samples n, total population. So what is the difference here? So the difference here is k. Here we have sampling interval and we create total population here. So we create samples based on sampling interval. We create samples based on total population where it comes to circular systematic sampling. Then the start and end points of the samples are distinguished. That means they are different. The start point and the end points are different. But what it happens here? It restarts from the start point. I'll take you back to the example. See here, A. That's why I mentioned it in the circular way. So you can see the process is continuing here. The process is continuing. Even if it reaches A, we will continue the process until we reach the maximum responses we need, or until we get the maximum responses. So it's a continuous process here. So that's why it is in a circular form. Whereas in a linear method, it is not a continuous form. We are going to have a different start point and a different end point. There is no particular end point to that. We can have n. It is n. We can reach anywhere to the any end point. But here we restart from the start point again once the entire population is considered. All sample units should be arranged in a linear manner prior to selection. So here all the sample units should be arranged in a linear manner. So what is linear manner here? It will be in the line. So to be simple, it is going to be in a line format, in a linear format. But whereas in a circular systematic mass sampling, it is going to be in a circular form or in a circle form. So that was for today's session. So in the next class, I'll be taking you to stratified sampling. What is stratified sampling is, how it got origin, and what are the different ways the stratified samples are used, and where it has its presence in the present sequences. So thank you for the session, guys.